This is the 2019 NCEA 2 exam. This is question 1c. And it says the polynomial, blah, can be written as a perfect square. Find the values of m. When we say perfect square, obviously we're meaning something like x plus b all squared is 0. Yeah. So that's what we're looking for. However, we want to make this so that it can be. So what values would m make that true if this could be or was a perfect square? So let's go ahead and find out. So the first thing we're going to do is we're going to solve for m. We're going to find what values m would be. So to do that, we're going to use the discriminant. So we're going to find the coefficients. And the coefficients, by the way, have very conveniently been laid out. Here's the coefficient of x squared, the coefficient of x, the coefficient of x to the 0. So a is 2m minus 1, b is m plus 1, and c is m minus 4. So as we do this, we get to the end, we're going to end up with some answers, obviously, for m, and probably quadratic. It looks like it's going to be a quadratic of some sort. That being the case, we're going to have to test to see if those values are true and if they make it a perfect square. So let's have a look at doing that now. So first things first, let's use the discriminant to go ahead and do this. Now, if it's a perfect square and it's in this form here, that means that if we were to draw this thing, and I was just drawing like x and y here, right here, y and x, then it's going, a perfect square is only going to touch at one point. It's going to do something like this, yeah? It's going to touch at one point, or maybe it's doing the other way, but it's only going to touch at one point. It's not going to cut the axis at more than one point. It is going to cut the axis, but not at more than one point. So in that case, we're going to say b squared minus 4ac is going to equal 0, meaning it touches at one point. So let's go through this and populate this equation with these values. So first of all, we've got a b. B is going to be m plus 1. It's squared, so I'm just going to write it twice just to, because I don't have a lot of room here, I'm noticing, and probably this might take a bit more space, I imagine. 4 times a is 2m minus 1 times c, which is m minus 4. All right, so I'm going to expand all that out. So this bit here expands out to m squared plus 2m plus 1 minus 4 times, I'm going to put some brackets here, I'm going to expand this all out. So 2m times m is 2m squared. Negative 1 times negative 4 is plus 4. By the way, all this equals 0. And then I've got negative 1 times m is minus m. And then I've got another 2m times negative 4 is minus 8m. All right. So let's collect like terms, see where we land. Or I'll expand this out first, sorry. M squared plus 2m plus 1 minus, so what do we got here? It looks like we got 4 times this is going to be 8m squared. 4 times, well actually, why don't we do this separately? M minus 8m is 9m, negative 9m, times negative 4 is going to be plus 36m. And then we've got negative 4 times negative 4 plus 4 is minus 16. All right, so that's where we end up. So now let's go ahead, collect like terms. So that implies that, this implies that, this implies that. So I've got an m squared and a negative 8m. That's going to be a, what do we got here? A 7m. Right, okay. So that's going to be minus 7m squared. What else we got here? We've got a 36 and a 2m. That's going to be plus 38m. And then I've got a negative 16 and a positive 1 is going to be a minus 15. That's equal to 0. Now I'm just going to multiply everything by negative 1, so I'm just going to make this positive, this negative, this positive. I always like dealing with a positive, makes life so much easier. So now I've got 7m squared, 38m, 15. So I'm going to have my two brackets. I'm going to see if I can do this with integers first, and if I can, so much the better. If I cannot, then we're going to have to use the quadratic formula. I've got a 7m here and a 7m here. All right, so things that 7 times 15. So I'll put a little side note here. 7 times 15. Let's have a look what that is. That should be 105, I think. 7 times 15, 7 times 15 is 105. There it is. So it's 105. And factors of 105, of course, 7 times 15, obviously. But 15 is, these aren't two factor rich. So we could go, what's that? 7 times 3. So that's 21 times 5. That would get us there as well, but it doesn't quite get us to where we need to. What about a bit further? I'll just make a bit more space here, actually. So 21. What about 7 times 5? That would do it. 7 times 15, 21 times 5. What about 7 3? What about 7 times 5 is 35, and 3. 35 and 3 would be factors of 105. How does that work for us? Well, yes, that works well. The signs are the same. They're both negative, and 35 and 3 does make 38. So 35 and 3 does make 38. I can divide all this by 7. 7 goes into 7m m times, minus that goes 5 times, and I've got a 7m minus a 3 over here is 0. All right. So m, therefore, I'm going to say m. It's me trying to work it out as I go along. M equals, well, m is equal 5, or m is equal to 3 on 7. So the question now is, are those true? Well, let's check m equals 5 first. So I'm actually just going to make a little insert here. Excuse me, a little insert here. Let's go back to the original equation, and I'm going to make all the coefficients here work with a 5, first of all. So I've got 2 times m minus 1. That's 2 times 5 minus 1. That's x squared. Plus 5 plus 1 m. Sorry, x. That's an x, sorry. Ugh. So all I'm doing is I'm substituting the value of 5 in to the m's here and here and here. And then the final one is going to be plus m minus 4 is going to be 5 minus 4, which is 1. There it is. So what I've got here is that's going to be 9x squared plus 6x plus 1. Is that a perfect square? Well, let's just check it. That's equal to 9 times 1 is 9. And we want 3 and 3. So it's 9x plus 3. 9x plus 3 works. There it is. Divide both by 3. Divide both by 3. 3 goes into 9x. 3x times plus 1. So it's going to be 9x plus 1 all squared. So that is a perfect square. Therefore, m equals 5. So for m equals 5 is a perfect square. I'll draw a picture of a square, which is equal to this thing here. There's my perfect square. Oh, sorry. 3 goes into 9x. 3 times. Crikey. What am I doing? I'm just going through, noticing mistakes, and I should be fixing these as I go. I'm so sorry. That's 3x. There it is. 3x plus 1. Ah, dear. That's just too late in the day. Okay, here we go. So there is my perfect square. Crikey. How could you write that down? Okay. Okay, what about this one over here though? 3/7. So let's have a look what that would be. So that's going to be 2. In fact, I'll write it up. I've got too much room down here. We will be all right. So I've got 2 times 3/7. There it is. Minus 1 x squared plus 3/7 plus 1 x plus 3/7 plus 1. That's going to be 6/7. So 6. I'm going to have to write. I'm sorry, I'm going to have to write this out somewhere else. I'm going to have to write that out over here. That's going to be 6/7 x minus 1. Oh, no. This cannot be a perfect square, yeah? I'm not even going to go through it all, yeah? I'm looking at this. This is not, so I'll put it in here, not a perfect square. Therefore, we must exclude m equals 3/7 as a solution. Yeah? So we must exclude 3/7. Why don't I write that so it actually looks like it's 3/7? M equals 3/7 as a solution. All right, so that's how I would write the answer. That is the perfect square, which we get if we get m. The other one is not a perfect square, and they don't get a lot of room to write the answer. I don't think if you end up using the quadratic formula, don't do that. Just go ahead and this factorizes perfectly well using integers. All right, hopefully that makes sense, and yeah, hopefully you didn't have to tease it out the way I did.